2,000 years ago, in the ancient city of Alexandria, one man set out to bring order to the chaos of shapes and lines. His name was Euclid. His book, The Elements, became the most influential textbook in history, and at the heart of it, hidden within 465 individual proofs, were just 5 postulates, simple, self-evident truths about the nature of space. The first 4 were simple, almost obvious. 1. A straight line can always be drawn between 2 points. 2. That line can extend forever. 3. From any point, with any radius you can draw a circle. 4. All right angles are equal. But the 5th Proclus wrote was different, complicated, mysterious. It said, if a line crosses to others and the interior angles add up to less than 180 degrees, then those lines will eventually meet. This became known as the parallel postulate, and it haunted mathematics for centuries. For over 1,000 years, scholars tried to prove it from the other 4. They failed. But in their failure, something unexpected happened. New geometries were born. Geometries where parallel lines could bend or curve or never exist at all. In hyperbolic space, the angles of triangles add up to less than 180 degrees. On the surface of a sphere, they add up to more. These strange new worlds could be reached by warping the rules of Euclid, by tweaking one simple postulate. By dropping the assumption that space is flat, we revealed a universe of new mathematical possibilities. It was as if, according to Brian Johnson, author of How to Die, a prisoner had been handed a key that opened every door in the castle, except for one. For that one door, the key fit in, but it didn't open. And so the prisoner spent his whole life trying to pick the lock. He never discovered the 4th wall. The parallel postulate also forced mathematicians to completely reimagine the foundations of geometry. After all, if we can't assume that parallel lines behave the way we expect, what else might be wrong? Maybe nothing, maybe everything. This crisis of confidence led to the development of new axiomatic systems, where you start with basic assumptions called axioms, then use logic to reach conclusions. This approach underpins the entirety of modern mathematics and has spread to other fields as well. It's allowed us to make sense of quantum mechanics and Einstein's theory of general relativity, which tells us that space isn't flat. Space can warp and curve and time can bend, all because of the way massive objects move through it. Without the stubborn mystery of Euclid's 5th postulate, we might never have developed these ideas. We would never have had non-Euclidean geometry, which predicts the behavior of gravity in strong fields like those around black holes, and which tells us how light bends around massive objects, allowing us to see things we otherwise couldn't. Without Euclid, space travel would be impossible. GPS would be inaccurate. Architects and engineers wouldn't know how to design structures or bridges or machines. Basically, modern civilization would look very different. So next time you look up at a building or down at your phone, remember the man who brought order to the chaos of lines and shapes, without whose simple truths our modern world wouldn't exist. And if you want to learn more about the incredible stories behind other scientific ideas and discoveries, you should check out our new series,